All right, so we know that we know that variables are considered perfect squares if they have those even exponents, like we saw in our previous examples. So that leaves the question, what about odd exponents? Let's see, is this ready to let me do anything? Okay, there we go. So odd exponents are like those non-perfect square numbers. When we have non-perfect square numbers, we look and we try to factor it into that largest perfect square. That's what we're going to do here. When we have odd exponents, we're going to take those and we're going to factor them into even exponents. We're going to factor them into even exponents, and we'll see what that looks like. Or we're factoring them into x squareds, like we talked about in that first problem. How many x squareds can I pull out of that? All right, so let's look at this first example. The square root of 7, my goodness. The square root of x to the 7th is what that says. So I want to break that up into even exponents. So how many x squareds can I break up the x to the 7th into? Well, the square root of x squared times the square root of x squared times the square root of x squared. That gives me 2, 3, 4, 5, 6. That doesn't quite get me back to 7, so I need that one last square root of just a plain old x. Because the 2 plus the other 2 plus the other 2 is 3, plus the other one is 6, one more to get to that 7. So now this is where it gets a little weird. The square root of x squared we know is x. And now keep that in mind here. This is where we get tricky. The square root of x squared is x, not the square root of x. We took the square root away when we canceled it out with the squared. Square root of x squared is x. Square root of x squared is x. And then this is not a perfect square. This x to the first power here, that's not an even exponent, so it can't come out of that radical nicely. So because it's not, that stays inside the radical as just plain old square root of x. X times x times x turns into x to the third power with a square root of x still inside there, inside the radical. So that's one way you can look at this. There is a second way. So that way was looking at breaking it up into how many x squareds. This way, we're going to look at just breaking it up into the largest exponent. Let's go blue. So if I'm starting off with the square root of x to the 7th, what is the largest even exponent that I can pull out of there? How many that's a weird question. So I can break this up into x to the 6th, right? Because I can't go up to 8 because I only have x to the 7th, times x to the first power. The square root of x to the 6th times the square root of x would get me back to the square root of x to 7, right? That's just like factoring a number differently. If I had the number 12, I could factor that as 6 times 2, or I could factor that as 3 times 4. They're still factors, even though they're different numbers. We learned back above that the square root of an even exponent just kind of cuts it in half. So the square root of x to the 6th is x cubed. 6 divided by 2 is 3. And then I still have that square root of x left behind because it's not an even exponent. It's not a perfect square. So 2 different ways you can get to that same answer. It might make sense to break it up further and then come back while you're starting off.